I'm Joshua Bardwell, and you're going to learn something today because we've got with us in the studio Ira Faberman. He is the head of Iftron Tech, and they make the Clearview receiver that you've heard about. And he doesn't know this, but I've locked the door to his room, and I'm not letting him out until he tells us how Clearview works. Stay tuned. If you watch my channel for any length of time, you know that I'm a big fan of Clearview FPV receivers. If you haven't heard of them, go look at one of my earlier review videos. The short version is that they're, well, to be honest, they're pretty expensive. The cheap one is $400 and the expensive one is $700. And many people and myself, when I first started testing them, wondered, could they possibly be, I mean, surely they just are overpriced and they're the same as everything else. But no, in my first round of testing, they did much better than everything else on the market. $400 better? Only you could decide, but many people feel that it is. And I've continued to use it, continued to test it. And in my recent round of testing, I was a little surprised to find that Clearview didn't just knock the socks off of everything else in the field. But I presented those results to you because it would be unfair, and you got to be objective, right? You got to present the results as they lie. Well, I ran into Ira Faberman. He is the head of Clearview, of Iftron. Sorry, I keep calling it Clearview. He's the head of Iftron Tech, the company that makes Clearview. I ran into him at Flight Fest East, and I said, hey, can we do an interview? Because there's all kinds of questions that I think people would like to hear you address. And one of the questions we're going to talk about is what was going on in that testing. But I got a whole bunch of other things that we're going to talk about as relates to Clearview. I think it's going to be really interesting. Now, there's two things I got to acknowledge, first of all, before we get into the video. And one of them is that despite my comedic intro, if you're expecting him to say, open the kimono and tell you exactly how Clearview works underneath, well, that would be a real coup for me, but I doubt he's going to do it. So let's just get that out of the way up front, right? And the other thing I have to acknowledge is that I don't know how it works, and I'm not an expert I don't design. So you guys think a lot of me, but I don't know how all this stuff works. So I'm going to ask him questions, and he's going to give me answers. And if he says that it has a flux capacitor, I'm really not going to be in a position to disagree. So this is not an interview of peers. This is, me like, hey, all right. So with all that out of the way, let's go ahead and introduce Ira Faberman. Ira, welcome to the show.
Hey, thanks very much. It's good to see you, Josh.
Yeah, and I thought we would start with just a little bit of an introduction to who Iftron Tech is and, where you guys came from. Because I think you didn't come from FPV originally, did you?
No, in fact, Iftron was downlinking video before FPV was actually a thing. I was fooling around with trying to get video images down from model airplanes. It's kind of the leading edge of it all before anybody even coined the term FPV.
Yeah. So back in the fixed wing days, and essentially what you make is a very good FPV receiver. Is that fair?
That's fair. That's part of what we make.
And you used to make diversity receivers, but in fact, Clearview is not, strictly speaking, a diversity receiver. Is that right?
That's true. It is not.
So I understand, like I said in the intro, I know you're not going to give away your secret sauce. Are you? No. But I thought we would talk at a high level, as high of a level as you care to, about what Clearview does. How does it work, and how does it different from a diversity receiver?
Well, Clearview does something that no other video system does. It processes and corrects the signal imperfections in real time. If you eliminate the requirement for real time, doing that kind of processing and noise elimination, things like that, stabilization, are pretty easy to do, and there's well-known techniques, and they're digital based. There's latency. Some more than others. Signal gets worse, the latency also gets worse. With Clearview, which is a unique suite of technologies that all work in harmony, we're able to do all of that in real time. In fact, some of our processing takes place in less than 20 nanoseconds. A nanosecond is 1,000th of a microsecond. I guess you could say that you can have video that's cleaned up, or you can have real-time video. But if you don't have Clearview, you can't have them both together.
Yeah, one of the things about Clearview is, whatever it's doing underneath, it's interesting you point out, it's not novel in some way, but what's really novel is that it's able to do it in, as you say, real time without additional or excessive latency. Is it excessive latency without, or is it literally real time?
Well, it's not only is it literally real time, but I would take some issue with the idea that it's not novel, in that it cleans up the signal.
Sorry. I thought that's what you were saying when you say, well, these things, the digital processing that exists previously. I didn't mean to insult your invention.
That's okay. I just want to make it clear that that all the processes we use are novel in of themselves.
So one of the things people have said, or people have accused, is that the Clearview just has a 5808 module on the inside and just a bunch of empty space and a fancy aluminum shell. So I wonder if we can we show the circuit board for the Clearview right here on the air?
Sure, we can do that. I think what we're talking about mostly, though, is the democratization of skepticism.
Nice.
The board, let me show you the part of the board that most people will reference when they say, oh, there's nothing inside the case. And here's that side.
Mm-hmm.
There's two modules.
Right, and those look like off-the-shelf. I mean, they look similar to what I see when I look at my LaForge diversity modules. So that's not...
Well, all these modules tend to look alike. They're not all alike on the inside, but they're similar.
Right. What we're seeing there is the metal case, the metal shield that prevents the RF stuff from interfering with the rest of the board. So they all have that similar shield there. Go ahead.
Right. And also, there's really only a chip manufacturer that these modules are based on. They're only based on one chip. There are actually two manufacturers out there. There is Airwave, and I don't think that their technology is old.
Mm-hmm.
So these chips, and that's why these modules tend to have similar functionality.
Yeah, and that's not really where the secret sauce is, if there is one. The RF module in a thing like this, its job is essentially to receive the RF signal out of the air and output it into the electronic circuitry of the board itself, where I say that's not where the magic is. Obviously, some RF modules are better than others in their ability to filter and tune in the signal. But I think if you flip that board over and show the other side, because right now people are going, yeah, well, it just looks like two modules on a board. But I think if you show the other side of the board, we'll see that there's a lot more.
Start by saying that, anyway. Turn this guy over.
Yeah. And now this is, of course, I have no idea what we're looking at here, but it looks like a lot of stuff.
There's an enormous amount of stuff, and I would say that 95% of the stuff you can see processing the signal is the modules.
Yep, and I will have, as I said in the intro, I will have to take your word for that. My favorite thing about this board has nothing to do with the technology. I don't know if the viewers can read this, but in the upper left it says, if you can read this, your warranty is void. And then there's three white squares, which I assume are QC checks or something. It says, assign blame here.
That's right.
So you got a heck of a sense of humor there. But yeah, we can...
well, we've actually had that on our boards since we started the company.
Nice. Nice. I like
long-standing job.
Of course, the first thing I did when you sent me mine was open it up and take it out and look at it. I don't know if you expected that, but I did. And when I saw, if you can read this, your warranty is void, I just cracked up. So, but I think that's pretty much all we're going to be able to, without being able to go into the details of what exactly it's doing. By the way, people are still framing that last one now, and good luck if you guys can figure anything out. But I think that's as deep as we're going to be able to go there. But suffice it to say, it's not just a 5808 module with, I don't know, it is a commodity module, but that's not unexpected.
Well, let me just add a little bit to that. They are not stock.
Okay.
They start stock, but they're not by the time we're finished.
So, for example, and you certainly may decline to answer this question if you like, but LaForge talks about, or UBAD talks about how with their LaForge, they've made modifications to the filtering on their module. I don't know exactly what they've done, but presumably they've added some capacitors and inductors and whatnot. And that's the kind of thing you're talking about, where you might start with a stock module but make some improvements.
Well, we've made improvements, but not what you described.
Okay, fair enough. So let's move on then, and let's talk. We talked about that Clearview is not a diversity receiver. So a diversity receiver, basically the way it works, tell me if you agree, is that it receives two signals and it picks the best one and it switches between them. And you talked about that Clearview is doing something else. And one of the things that you told me when I got my first Clearview is, don't put a directional patch and an omni antenna on it and expect it to work. I mean, it'll work okay, but the way it's designed to work is, in fact, that you have two of the same antenna and then it's doing something. And so I thought, what are the other ways in which, from a user's perspective, not from a under the hood perspective, but from a user's perspective, Clearview differs from a traditional diversity receiver?
First, let me start by saying that the notion that you need two identical antennas is all my fault. Back in the early days, technology as we do, we thought that would be best for people to use two identical antennas. But in more recent testing, and the knowledgeable FPV guys, taking the other antenna completely off, the receiver, they tell me that the Clearview receiver retains 75 to 80% of its improvement over standard receivers with only one antenna. And that certainly flies in the face of my original statements, and I accept that, and it's still a rumor that's out there. You can use a patch and an omni at the limits when your omni is no longer effective and only your patch is effective. Patch and only your omni is effective. You're going to lose some of the performance, but the performance hit is not so much that you would think it was back as bad as conventional video. Indeed, it's almost as good as it is with two antennas.
So I guess what I'm hearing is that you should tune the antennas to where you're going to be flying. So, for example, if you were located in the middle of your flying area and going to be flying in a rough sort of circle around yourself, you would get an improvement by running two omnis. But if, for example, you're maybe at the edge of a flight area, but you might fly behind yourself, you could mix a patch and an omni together. And if you're at the edge of the area and only flying in front of yourself, maybe two patches would be best.
Yeah, and I would say it's not, because the performance hit is so relatively minor, you might not even notice it. I would suggest that people just play with it. Just try it, because I think in many cases you won't even be able to tell that you've got two different antennas on there.
Mm-hmm. Yeah, so there were some other differences that I had in mind. That, like, for example, and this will get into a little bit, I think, the difference between the pro and the racing receiver. So let's back up then. So you've got the pro receiver and the racing receiver. The pro receiver is about $700. The racing is about $400. Is that right?
Right. The racer is $379.95, and the pro is $679.95.
Okay. And I know that there are some behavioral differences between them. For example, I think, if I remember right, one of the differences is the way that they auto-select between PAL and NTSC. Can you speak to some of the differences between the pro and the racing, both from a, like, what do you get for the additional $300, but also from a user? I know I get confused sometimes, and I ask you a question and you say, oh, was it in pro or racing mode? And I'm like, oh yeah, I always forget that.
The pro has a much more extensive set of features and options. The spectrum analyzer is a much more refined application, and in fact, for most of the differences, I'm going to put the audience to sleep if I start enumerating them. So I'm going to ask you to a little chart we've got so you can read what the differences are.
Okay. Yeah, I'll put that up on screen and provide a link to it. Good idea.
Okay. But there are some differences I do want to speak about. In particular, is how the pro and the racer handle interference from other transmitters, and they are distinctly different. Go through them quickly. For a pro receiver, the quad may have multiple cameras. it's important to unlock from the previous signal and lock up to the new signal as quickly as possible. Racing receiver, guy who's in a race, if he's flying on the track and somebody else's signal, steps on him, you don't want Clearview to drop the original signal and go running chasing the new one. So for a period of 5 seconds, it stubbornly will not unlock, regardless of how much interference there is. Now that means you might see a ghost of the other image screen, but your image will remain on screen and stable. 5 seconds. After 5 seconds, it will unlock and we'll chase the new signal. And we think that 5 seconds is more than adequate time for, in a race, that interfering signal would be gone.
Yeah, and this provides us an opportunity to segue into the results of my testing. And actually, there's a test I did that I haven't released the results of yet, where I did interference testing. I took one device is on, say, 5800, one device is on, say, 5760 or 5740 or something like that. And I move the interfering, and the receiver's on, say, 5800. I move the interfering one closer and further away, and I see which receiver holds onto the signal the longest and which one breaks up and shows the interference. And the Clearview did actually one of the worst of the others in those results. And it sounds like one of the things you're saying is that because I was in pro mode, that's I always run my Clearview in pro mode because, of course, I'm a pro, right? But because it's in pro mode, you're thinking of a paradigm that many of us quad guys don't even think about. The idea that, you remember, like a fixed wing plane with a forward facing camera and a downward facing camera and a wing camera, and you're going to switch between them. It sounds like you're saying the Clearview may have intentionally been switching to the new signal more aggressively, and if I had put it in racing mode, that wouldn't have happened.
Exactly. But of course, in racing mode, you only have 5 seconds of grace time.
Right. The idea being that like the interference scenario we're imagining for a race is that you're flying on the track and you're out at the back of the field because that's just where you are in your lap. And some other pilot flies in front of you really close to the pilot station. And for a short period of time, you pick up his signal, but he's not going to be there for 5 seconds unless he just lands and sits there, in which case, screw that guy. But the idea is that the Clearview is going to try and reject that interference, but eventually it'll go, oh, well, I guess it's my new signal now.
That's correct. That's a good case.
Yeah. And in my testing, of course, I was moving slowly and standing in one place, and so that's when the Clearview switched over. So that's interesting to think about. Maybe I should rerun the tests in racing mode.
But once again, if you do that, you only have 5 seconds of grace.
Right. So I should, I don't know. The more I get into this testing, the more I try to make it better and better, and the more I just keep finding flaws in it. It reminds me, I did a video a little while back where I talked about why the usual method of measuring camera latency is just completely flawed. And the usual method is that you take a camera and you point it at a stopwatch, and then you look at the screen and you look at the stopwatch and you see how much difference there is. And you can go watch that video, viewers, if you want to. But the more I dug into that, the more I realized that there are a whole lot of complications there, and it's really hard to get it right. And I'm having that happen with this receiver module testing now. Every time I release a test, there's something about the results that is not quite right, and I try and think of some way to make it better. And it just keeps happening, and it makes me think that every other test I've ever seen anyone do is probably nonsense, because if mine aren't perfect, then nobody else has put as much work into it as it feels like I have. But I'm sorry, I'm just whining now. We're not even talking about Clearview anymore.
Scientific tests, it's important to publish your methodology, right?
Oh, well, I agree about that. Everybody wants just this one won, this one lost, buy this one. Oh, buy that one. But in reality, I mean, I come from a little bit of an academic background. I never went to grad school, but I feel very I like the scientific method, and one of the things about that is that you publish your results, and other people can look at not just your results, but also your methods, so that other people can look at the methods and see, well, hang on, he did this and that, and we would do this differently. Yeah, of course, it also opens you up to a lot of criticism, but now I'm just whining again. So I do want to ask you though, and I think you watched the other video, the basic sort of range test videos, and I'll recap for the people who may not have seen it. Go watch them. I'll recap for the people who may not have seen them. I put 2 Omnis on the Clearview, The other devices had both a patch and an Omni, so it's a little bit unfair, but in the past, I've seen the Clearview have about 6 to 8 dB of advantage. So a Clearview with a 2 dB and Omni antenna on it would do about as well as a LaForge with an 8 dB patch antenna on it. They would be about equal. But in this testing, I feel like the Clearview didn't really excel, and I feel like the difference was even not just explained. I mean, I tried the test again, giving the Clearview 2 patch antennas, so it was sort of on fair footing, and I still feel like it didn't quite do as well. And I wonder if you saw that testing and if you have any thoughts about, well, it sounds like what I'm asking is, what could I do better to make Clearview win? And that's not what, I mean, that would not be honest or intellectually, rigorous. But I've seen Clearview do so much better in so many other conditions. It just feels like I screwed up somewhere that it didn't do better under these conditions. I don't know.
In the case of your more recent testing, I think that the elephant in the room that you used.
Say that again, please. Sorry, you broke up briefly. Say it again.
DVR.
That's right. And just in case, again, for the viewers who may not have seen it, I got an 8-channel security camera DVR. The idea being that I want to eliminate any sort of dropped frames and differences in the receivers. And I fed all the signals into an 8-channel DVR. And then I took the output from that screen and I fed it into another DVR so that all of the channels were synced and being received equally and so forth. Go ahead, Ira.
Well, these DVRs digitize the signal, and then they have all day to clean it up. What I see is not so much that we did poorly, is that everybody else did better than expected. DVR was cleaning up their mess. I would suggest that if you had the ability to get a picture of what the pilot would see in his goggles, was putting out, you would see a dramatic difference. I'm talking about just using a LaForge or any other module, not a Clearview. That how much help the DVR gave those videos, but couldn't help us any further.
Right. So, so what we might do, and maybe I'll do this, is do a comparison of exactly. I mean, we keep coming back to what I keep trying to avoid, which is that you got to point a camera at the goggle and record what the goggle is actually showing. And
it's not an easy test to do.
Yeah. So the other place, the other thing I want to talk about, I think this is the last thing we're going to close on, is we had a conversation at Flight Fest that I thought was really deserved to be expounded upon, and that is about digital versus analog. I said, why can't we make good digital video? Why don't we just give up on high def? Why don't we just make standard def? I mean, couldn't we do that? And nobody's doing that. And you seem to have some thoughts on that. What are your thoughts about digital versus analog and why you've gone with analog?
Well, there's no doubt that if you decrease the resolution, you're going to decrease the amount of time it takes to create a frame. And so you're going to get, for a given bandwidth anyway, less latency. But that's not all there is to it, because in a digital system, when the data for part of the picture goes bad, the digital system will almost invariably show you the old information. That tree coming, but you've already hit him because half of your screen, there was some noise or something like that, and you're seeing the tree from 3 feet away when you're actually, 2 feet past it, so to speak.
Yeah, and
that mixture of old information and new information just can't process mentally.
Yeah, and I've seen that when I flew with ProSight. I flew a little bit with ProSight. I don't own one, but I flew Paul Nurkola's one when I was out visiting him. And it's a kind of I call it smearing. Like when you start to get the breakup, the picture doesn't distort or go staticky. The information is still there, that tree or whatever. But then as the rest of the picture changes, it kind of smears. And it's not, when an analog frame breaks up, you can tell the difference between the static and the actual picture. But when the ProSight rather broke up, it wasn't obvious what was good information and what was bad.
Because you're mixing old and new data.
Mm-hmm.
And that's the reason.
So is your premise then that is there a path forward for digital high def? Or is that just like, do you think that's a non-starter?
Well, let me say that my very talented software engineer and I, before we set out to invent Clearview, we surveyed possible with digital. We determined that the problems that digital would have, no matter how we tried to do it, were based in physics, not in what chip was available here or there. And so those problems, we decided we're going to play digital for a very long time. Now, we don't know whether that long time is going to be 5 years, 10 years, or maybe never solve those problems. But those problems are real and they're based in very basic science. So we decided to do Clearview instead of digital.
Mm-hmm. Your premise is, or your hypothesis is, that really high quality analog is going to be superior to anything digital can do at a price point. Obviously, if you have Pentagon money, then you could do almost anything you want. And there are digital solutions out there, not just ProSight, but I heard about another one. I think it's called Sky Blue. I apologize if I've misremembered their name. There's at least those two guys out there who are trying to do this. Sky Blue hasn't been released yet, and I don't know what its price point is, but if you look at ProSight, it's about, pardon me if this data is out of date, I know the price is always changing, but I think ProSight is about $400 for the full setup, and that includes one receiver and one camera. And then I believe it's about $200 to $250 for an additional receiver and an additional camera, and that cost is on every single quad that you own. So if you have 10 quads or whatever, I recently did a survey, and as part of the survey, I asked people how many quads they own, and most people had fewer than 3. But that still means that you're going to have a $400 additional price if you're outfitting with digital, compared to, let's say, about $100, $120 for a really good camera and like a really good video transmitter, like a Unify, or maybe less, depending on if you're going more budget. And I think that, that even at that price, you still don't. I mean, ProSight it's good. It's surprisingly good, but I feel like it's not quite there, and it's a lot more expensive than analog.
You're only going to get the high definition of that digital seems to promise if you're willing to live with so much latency that you can't fly it. If you take away the high definition part of it, then you're going to look at a kind of a noise, which you're described as smearing, which is a mixture of old data and new data, which is very hard, if not impossible, to mentally process, especially when you're flying. So digital is not going to help you there either. That people are unconsciously responding to when they express an interest in digital, and that's the wide screen. That's the 16:9 aspect ratio of a digital picture. It's very attractive. It seems to be more to look at. It's more comfortable for a binocular animal to be able to see that wide vista. Recently bought a RunCam Monster. I'm not sure what the brand. I'm sorry, it's Foxier Monster, which is a 16:9 analog camera.
Mm-hmm.
Sent the picture to Clearview, sent it to a widescreen monitor, and I tell you, it rivals digital. The problems we've been discussing.
It's interesting, and that's a radical claim. But I have to say, I mean, we talk about so first of all, there's no reason an analog feed can't do 16:9, and people who fly Foxier Monster or RunCam Eagle know that that's the case. People who own a Dominator V3 goggles have a 16:9 display and 16:9 cameras, and they're happy. But the setting aside the question of the aspect ratio, resolution is the other question, and people talk about how how many lines are in an NTSC picture. How many horizontal lines?
525.
525. So they say, well, so that's your max resolution, but don't forget that is your horizontal lines. But actually, if you look at the camera's TV line spec, you're about like a 1200 TV line camera. And I always used to wonder, what does that mean? I mean, NTSC has whatever 525 lines, and that's just it. But you got vertical resolution.
When you see a camera that quotes its lines, what they're actually talking about is vertical lines looked at through the camera, which turns out to be horizontal resolution.
Right. And the horizontal resolution of these cameras can be quite high.
And in fact, you can't get that information to the ground. Anything past roughly 600 lines, maybe 650, maybe, is all that you can actually send with the given signal bandwidth.
So are you saying then that the effective maximum resolution of an analog feed is about 525 by 600?
True.
And yet somehow, when you put that picture on a widescreen TV, you're saying it rivals digital. A lot of people are going to be skeptical of that because we all, you go from a 640 by 480 image to a 1080p image. Clearly, there's a difference.
Well, I didn't say 1080p, I just said digital.
Fair enough. Fair enough.
Turn your digital resolution down to where you have acceptable or low latencies, then we have a competition here.
And there's a distinction here that I think is relevant, and that is that just because you have a 1080p or 1080i signal coming out of your receiver doesn't necessarily mean that you have that much actual resolution. And the great example I like to use is when I watch Netflix, right? Netflix may have, it's putting out a 1080p or a 4K image to my television, but the actual incoming video is maybe so compressed that it doesn't actually contain that much resolution. And if you don't believe me, compare a 1080p Netflix image to the exact same image on a Blu-ray disc. The Blu-ray disc is going to be at about 30 megabits per second, which is a ton of bandwidth, and it's going to look way sharper unless you have a really good Netflix feed. And so the actual resolution of something like a ProSite, again, we'll get the ProSite guys in here and they can tell us more about it, but it may not, just because you got that 1080 signal going into your goggles doesn't necessarily mean there's 1080 actual lines of resolution going in. Is that what you're sort of getting at?
Yeah, in fact, I'm not the only guy getting at that. I've got a lot of high-end pilots that say quite freely that by the time they turn down the ProSite resolution, the low latency that they need to fly effectively, that they can't tell much difference between the picture.
All right, Ira, anything else you want to add before we close?
No, I just think it's worth stressing the point, although I know this sounds very commercial, that you can have cleaned up video, or you can have real-time video, but you really can't have both unless you have Clearview.
All right, Ira, thank you for coming on. And of course, people, I hope you'll keep an eye on the comments. I know you've always been active in our comment section before. I appreciate that. It's always nice when vendors take an interest and actually participate. So I hope if anybody has any questions, if anybody wants to stick up for ProSite, and again, I extend the invitation if somebody from ProSite wants to come on here and do interviews about this stuff. And any other questions people have, leave them in the comments. Thanks for watching. Happy flying.